Well, it is Dr. Wright, and today's random and psychology topic is your limbic system. So let's talk about it. The limbic system is actually a collection of small structures. It's not just one single unit. And the limbic system is going to influence complex behavioral patterns. Think things like emotions, behavior, motivation, memory. Um, most of the parts of the limbic system are going to be contained in the middle of the brain underneath your temporal lobes. Temporal lobes are here, right? And the major structures of the limbic system include the thalamus, the amygdala, the hippocampus, and the hypothalamus. There are other parts such as the basal ganglia, the septum, and the cingulate gyrus, but those are less likely to be studied, less likely to be discussed. So the limbic system really deals with what we call the five F's: feeding, fighting, fleeing, feeling, fornicating, which is sex. And it controls parts of the brains that are related to love and to anger, crying, fear, rage, anxiety. We know that it develops throughout childhood. So we are not born with a completely functioning limbic system. Between the ages of 3 to 5, people have noticed that their children tend to have big emotions, and it is one of our jobs as adults in this child's life to help them effectively deal with those big emotions. And so, what's happening is that the limbic system is growing, and the child is having trouble dealing with all of these extra emotions that they're experiencing. This may also be the time where you start to hear about anxieties from children, things that they're worried about, and that's again because of the increased functioning of the limbic system. So what happens if our limbic system is overactive? As adults, we may experience long-term stress, which can have damaging effects on the body. So if we feel like we're constantly overstimulated, we can do things about it. One of the things that can really help is physical exercise. Even just walking can be helpful. We also can do meditation, mindful breathing, mindful movement, deep breathing, breathing exercises. All of those things can help us to decrease that fight or flight response that we're experiencing. So let's talk about the bits. Let's talk about those four important pieces. So the amygdala is going to produce reactions of rage and aggression when it's stimulated. And the septum, which we had mentioned earlier, does the opposite when it's stimulated. So that helps our brain to calm down. Um, the amygdala interacts with other brain centers and can dampen or delay responses in humans. So if you think about it, in animals, the fight or flight response might not be regulated because they're less able to like have a pause, use the frontal lobe to think about like, should I punch this person in the face? Well, animals aren't punching people in the face, but you get what I'm saying. But so as humans, as we get older, the amygdala is able to be kind of regulated by other parts of the brain of, let's not do that. That will get us in trouble. The amygdala and the pons are connected and relate to depression. So increased activity between the two of them can be influencing your depression symptoms. And the amygdala also plays a role in fear. So damage to the amygdala can cause a person to have absolutely zero fear whatsoever. Move on, talk about your hippocampus. The hippocampus deals with the formation of memories, and damage to it can cause the inability to transfer our current experiences into short term, into long term memory. So, development of new memories after the damage to the hippocampus can be impacted. Um, and it may actually be more involved with detailed memories and fear related memories than kind of the general part of memories. Your hypothalamus is going to play a role in motivation and emotional reactions. And it also influences the endocrine system, which is involved in emotionality. The hypothalamus is going to monitor our internal bodily functions and basically wants to maintain the body at homeostasis. So it modifies things such as hunger, temperature, and thirst. And damage can result in overeating or not feeling thirsty. We also know that the hypothalamus plays a role in aggression and acts as a regulator for hormones. It has also been implicated in the development of sexual orientation. And then finally, we have our friend, the thalamus. The thalamus sits below the cerebral cortex and is involved in the cerebral cortex's functioning as well. And it kind of acts as a relay station for impulses traveling to and from the cortex. So basically, sensory information, aside from scent, comes into the thalamus, and the information gets collected, organized, and then directed to the correct part of the cortex. And so that is your limbic system.